Hi everyone. Today, many websites offer third-party access to their data through web APIs, but manually encoding URLs with arbitrary endpoints, parameters, authentication, and pagination, among other things, makes API use challenging for programmers and impossible for novices. In addition, each API offers its own distinct data model, properties, and methods that a new user must learn even when the sites manage the same types of data as many others. In this work, we built a client library that allows users to interact with API's data by directly manipulating standard local objects in their own programming environment without invoking any API methods. In addition, we simplify building applications over API's data without any programming at all. We do so by designing a standardized machine-readable ontology that describes almost all web APIs as a collection of standard-typed objects. Consider the scenario where a user who tends to search for restaurants on Yelp and Foursquare to compare their ratings and reviews now wants to build one application that would allow them to search for restaurants on both sites at the same time. Now, this seems like an impossible task for a non-programmer to do, but for a programmer like this user, it seems like a doable task. This user knows that both sites offer APIs that allow them to access these sites' data. So what would it take for the user to use these APIs and build such an application? They first go to the Yelp API documentation, then they write code to make an HTTP request to the Business Search API endpoint. Then they need to specify the parameters, set up the authentication, they get the result, then they iterate through the result pages to fetch more results, then they get the result as a long nested JSON response, so they need to write more code to parse the results to finally get the exact properties that they need. But they realize that the reviews are not returned by this endpoint because Yelp requires you to make another HTTP request to get the business reviews. So they write code to make that HTTP request, and finally they get the reviews. Well, they're not done yet because now they need to write more code to connect these two endpoints, where for every business they need to make an HTTP request to the reviews endpoint to get its reviews. And now they get the exact data that they want. So they take their Yelp data and they plug it into an HTML templating language that reads and displays an object properties. And now they have an application that reads Yelp data. Well, they're not completely done with Yelp, because now they need to write more code to make this application dynamic, meaning reads from an input and search Yelp API and displays the result. And now they're done. Now the user needs to check the Foursquare API, and they're thinking, oh, we got this. Foursquare is pretty much like Yelp, so its API must be the same. Well, they're pretty much wrong. They start with the Foursquare API by writing code to make an HTTP request to the venue search endpoint. They are shocked to realize that this endpoint does not return most of the properties that they need. They go over the API documentation, and then they realize that they need to make another HTTP request to the venue endpoint to get the rest of the properties. Then make another HTTP request to get the reviews. And finally, they write more code to connect these different endpoints to get the data that they need. Wow, what a tedious process for getting just 12 properties. Now they take their Foursquare data and replace the Yelp data in their application with the Foursquare data. And whoops, the application will not work. Well, of course it won't work because Yelp's data has a completely different schema than Foursquare's. So the user will need to write code to consolidate these two different schemas, then write more code to search these two sites at the same time. A system that we have previously built called Scraper helps minimize some of that human labor for Yelp and similarly for Foursquare. Scraper allows programmers and non-programmers to access individual API endpoints without writing code. But Scraper, among other things, does not help connect these endpoints, and it certainly does not integrate data from different APIs, which leaves non-programmers unable to build such an application. An investigation we conducted on web APIs revealed that these APIs can easily be clustered based on the types of data that they offer. And although these sites are semantically similar, technically they are not. And we saw that with Yelp and Foursquare. Their APIs work differently and their data models look completely different. Now, Yelp and Foursquare, believe it or not, are fairly simple APIs. They have a couple of types and they only allow us to read their data. To get a better understanding of how APIs work, let's quickly look at another set of similar sites which offer write as well as read to their data. Let's take these three video sites. These APIs offer an average of 14 types and an average of 130 API endpoints. Looking at one of the types that these sites offer, which is playlist, there are so many things that can be done with the objects of this type. We can read and update playlist properties, we can create a new playlist and remove an existing one, among other methods, and we can also search these sites for playlist. To be able to perform these simple tasks with these three APIs, we need to write code that performs an average of 9 HTTP requests to connect these requests together, then consolidate the data models of these different sites. Semantically, many of these APIs are object-oriented. Many endpoints accept an ID identifying a particular object, and there are endpoints for creating and deleting objects and for reading and updating some or all of the properties of an object. However, the semantics of these operations are not exposed by the endpoints. Instead, they can be found in the human-readable documentation. Users must read the documentation to learn which endpoints manipulate which of the various site objects. So can we expose the site's data to users as no different from the data a user would work with in their own local environment? In particular, can we present the data as objects of different types, each with specific properties that a user can get and set, which can be created or deleted, and possibly with methods that can be invoked on objects of a given type or on the site? Even more ambitiously, can we interact with the playlist objects in the same way across different sites? Well, given that these APIs are not standardized, it might be possible to reach our goals if we can standardize the descriptions of these APIs. So we built Shaper, which consists of a standardized API description that we called Whoopi that maps the API's object to standard data types and methods. Given a Whoopi description, Shaper can automatically generate a client library that presents the site's data as objects in the application's local environment. Shaper integrates with Mavo, a library that empowers non-programmers to create interactive applications simply by authoring HTML. And finally, Shaper provides a graphical interface that permits any user, even a non-programmer, to describe any API using Whoopi. To be able to design Whoopi, we needed to determine how general such a description would need to be in order to capture the diversity of current web APIs. So we picked a random sample of 40 web APIs from the Programmable Web, a catalog of more than 24,000 APIs. We then analyzed these APIs to understand what was common among them. We found the following commonalities. All of these APIs offer objects of various types, all identified by ID. They have one endpoint per type that accepts an ID and returns the object's basic properties, generally those that are small data types. They also provide other endpoints for accessing each large property of an object, such as a video file or an array of associated objects. And these are among other commonalities that can be found in details in our paper. Based on these findings, we designed Whoopi, a machine-readable description that would permit automatic generation of a library that presents an API's data as a collection of typed objects in the local environment, such that reading or modifying the object's properties would automatically trigger the invocation of appropriate API endpoints to perform the requested modification on the site. To achieve our first goal, Whoopi builds on Happy Description from our previous project Scraper, in which even non-programmers can author. Happy provides the API endpoints URL, parameters, the schema, response data, pagination, and authentication, and Whoopi maps an API of any methods and parameters, as described by Happy, to a normalized API of typed objects with read, update, create, delete, among other methods. Whoopi also supports standardization of objects over multiple APIs. Whoopi describes how to map property names and objects returned by the API into schema.org standard types and properties. Schema.org is a site that offers a common set of schemas for describing objects and their properties on the web, such as news articles, discussion forums, and events, among other types. To verify that Whoopi does support most web APIs, we picked another random sample of 60 APIs from the Programmable Web and found that 90% of these APIs can be fully described by Whoopi, such that a JavaScript library, which we call Shaper.js, can read Whoopi description and automatically generate objects and methods to query these APIs and manipulate their objects. Now with Shaper.js, users can read and write properties of these objects and invoke methods on them or on the site, as if they were local, and the library takes care of making the necessary API calls to provide or modify the relevant data. And given that Whoopi maps the objects to standard schema.org types, it permits application written using Shaper.js over one site to work unchanged over any other site providing semantically equivalent data. To allow novices to build applications using Shaper.js without writing any JavaScript code, we integrate Shaper.js with Mavo, which is an HTML templating language that reads and writes objects' properties. Using Shaper with Mavo, HTML author can build applications to search one site's API or multiple APIs offering the same types of data, allowing our users to build this application that searches both Yelp and Foursquare at the same time without writing any JavaScript code. Users can also filter the data, giving the set of parameters supported by these APIs. In addition, Shaper Mavo supports getting objects from these APIs by their ID. The simple application reads a playlist from Dailymotion and plays its videos. To allow users to create the Whoopi description, we built Shaper UI, a graphical interface that lets any user, even non-programmers, to describe these APIs. In this demo, we are showing how a user can use Shaper UI to describe part of the Dailymotion API, specifically its playlist and videos. First, the user enters the URL of the site or the API, then Shaper UI, if permitted by the user, will generate a preliminary schema using some heuristics that maps the API's endpoints and field on the right to the schema.org types and properties on the left. The user can then add and remove types and properties. And they can also describe the search functionality to let other users search the API for videos or other types. And they can also describe how to create a new objects and delete existing one by connecting these methods to the appropriate API endpoints. When the user is done, they can save the description, and Shaper UI will generate Shaper.js and Mavo code snippets for the user to copy and use in their application. We evaluated the effectiveness of our system through a series of user studies. For Shaper.js, we conducted a between-subject user study comparing our library to the popular Swagger API integration library. Participants who used Shaper.js completed their task with an average time of 8 minutes, and 5 out of 6 participants who used Swagger client completed their task with an average time of 45 minutes. For the Shaper Mavo user study, we recruited 60 participants, 8 programmers and 8 non-programmers, and the average time that they both spent to build an application interacting with multiple APIs was only 4 minutes. Thanks for listening, and feel free to use our tool.